Okay, a couple examples using the quotient rule, okay, the other big rule in this section. Okay, so first of all, we'd like to compute the derivative of the function x plus 3 over x minus 1. Okay, well, that's a quotient. It's a fraction of two functions, and so basically we have to use this quotient rule. Okay, so shortly here I kind of wrote a short version of the quotient rule itself. The derivative of f divided by g is g times the derivative of f minus f times the derivative of g over g squared. Okay. Now, if you're careful and you write down this rule or you're looking at it in front of you, and as long as these functions aren't too complicated, you can probably just write the pieces down after you've had some practice with derivatives. So what do I need to write down to actually get the derivative of this fraction? Okay. Well, it says g times f prime. Okay, so the function in the denominator, x minus 1, times the derivative of the function in the numerator. Okay. Well, the function in the numerator is x plus 3. The derivative of x is 1, derivative of 3 is 0, so the derivative of x plus 3 is just 1. Okay. Now from that I need to subtract f, which is the function in the numerator, okay, the original function in the numerator, times g prime, which is the derivative of the function in the denominator. Okay. Well, this is x minus 1, the derivative of x is 1, and the derivative of 1 is 0. So the derivative of this whole denominator is just 1. Okay. And that's all divided by the original denominator squared. Okay. So if I simplify here, it looks like I'll get x minus 1, okay, minus x minus 3 all over x minus 1, the quantity squared. Now you have to be kind of careful with the quotient rule because there's this minus sign here. So technically I need to do two things. I need to multiply these together. Of course, when I do that, I'll just get x plus 3. But then I have to subtract both of those terms. So minus x minus 3. Okay. Well, I need to borrow a little bit more space over here. These x's cancel, and it looks like I'll just get negative 4 over x minus 1, that whole quantity squared. Okay, so that's the derivative of this function. Okay. Now what about this one? Well, again, same situation. The function I'm trying to find the derivative of is a quotient. Okay. So the quotient rule says if you have a quotient, you take the function in the denominator times the derivative of the function in the numerator. Okay. Now this time we have a little bit more complicated function in the numerator, x squared plus 2x. Okay. Well, the derivative of x squared is 2x, and the derivative of 2x is 2 times the derivative of x. Derivative of x is 1, so the derivative of the numerator should just be 2x plus 2. Okay. Now from that I need to subtract the numerator, x squared plus 2x, okay, times the derivative of the denominator. Well, the denominator is x, so the derivative of that is just 1. Okay. And this is all over the denominator squared. Okay. And, you know, if the functions are somewhat simple, you can probably just look at them, at least after you've had some practice in the past few sections, and write down what their derivatives are. You know, if these functions are more complicated, you might need to make some work out of computing these derivatives. But I'd say it's probably actually a good idea to start trying to do these derivatives a little bit in your head, and even checking your work if you can, you know, on paper. But you know, we want to become pretty fluent with computing the simpler derivatives. Okay. So what do we have here? Well, we've got, let's see, 2x squared plus 2x. I just distributed the x inside the parentheses. This product is something times 1, so really multiplying by 1 doesn't change anything. So I'll just get minus x squared minus 2x all over x squared. Okay. Well, and I can combine some terms here, it looks like. These two x's are going to cancel. And it looks like I'll just get, let's see, 2x squared minus x squared. Well, that's x squared over x squared, isn't it? Okay. Which is 1. Okay. So wouldn't you know it, after a little bit of work, the derivative of this function just happens to be 1.